Have you ever wondered how we fixed one of Earth's biggest environmental problems, only to create another one in the process? That's exactly what happened when we replaced chlorofluorocarbons, or CFCs. CFCs were once used everywhere, in refrigerators, air conditioners, and even spray cans. They were stable, safe, and convenient. But then scientists found out that CFCs were destroying the ozone layer, the thin shield that protects us from harmful ultraviolet rays. So, the world united under the Montreal Protocol of 1987 to phase them out. It was one of humanity's biggest environmental victories. But replacing CFCs brought new challenges, and that's what we'll explore today: the dual role of chlorofluorocarbon substitutes in climate change and atmospheric chemistry. When scientists started phasing out CFCs, they needed something that could do the same job, but without destroying the ozone layer. This led to the invention of HCFCs, hydrochlorofluorocarbons, and later, HFCs, or hydrofluorocarbons. These substitutes were designed to be safer for the ozone layer because they break down more easily in the lower atmosphere. That means they release much less chlorine, the element responsible for ozone depletion. And it worked. Thanks to these substitutes, the ozone layer has been slowly healing. According to the United Nations Environment Program, it could return to its pre-1980 levels by the middle of this century. So, from a chemistry point of view, these substitutes were heroes. They helped stop the thinning of the ozone layer and protected life on Earth from harmful UV radiation. But there's another side to the story.
Let's take a moment to see how this plays out in real life. Every refrigerator, every air conditioner, every cold storage unit, they all use these gases. And globally, cooling is one of the fastest growing sources of greenhouse emissions. As the world gets hotter, more people buy air conditioners, and the cycle continues. If we don't manage these substitutes wisely, HFC emissions could warm the planet by up to 0.5 degrees Celsius by the end of this century. That's half a degree just from one group of chemicals. But the good news? Many countries are already acting. India, for instance, has its India Cooling Action Plan, aiming to reduce HFC use, improve efficiency, and promote green cooling technologies. Major companies are investing in eco-friendly refrigeration, supermarkets using carbon dioxide systems, cars switching to low GWP gases, and new buildings designed with sustainable cooling. This transition isn't just about chemistry, it's about innovation, economics, and justice. Developing nations need cooling for food storage and healthcare, but they also need affordable, climate-safe solutions. So, the challenge before us is to balance human comfort, technological progress, and planetary safety, all at once. It's not easy, but it's possible. And we've done it before with the ozone crisis. At the heart of this story lies a simple truth: science doesn't stand still. When we first created CFCs, they seemed perfect. When we replaced them, it felt like victory. And when those substitutes caused new problems, we didn't give up, we adapted again. That's the real beauty of human progress. We learn, we evolve, and we keep trying to do better. The dual role of these compounds teaches us that nature operates as one interconnected system. Every chemical we release, every policy we make, and every product we build affects something else, somewhere else. The Montreal Protocol showed us what's possible when nations unite for a common cause. It's the only global treaty that every single country has signed, and it's working. The ozone layer is healing. The Kigali Amendment continues that legacy, proving that climate and chemistry are not separate fights. They're part of the same mission, protecting the thin layer of air that makes Earth livable. But our job isn't done. We still need innovation, engineers designing better cooling systems, chemists developing new compounds, and citizens making conscious choices about energy and consumption. If the 20th century was about discovering the problem, the 21st must be about solving it, intelligently and sustainably. So, the next time you feel cool air from your AC or open your refrigerator, remember, inside that machine lies decades of science, global cooperation, and a constant effort to protect the planet. Because the atmosphere doesn't have borders. And every molecule, whether of CFC, HFC, or carbon dioxide, tells a story about us, our mistakes, and our hope. The story of CFC substitutes is not just about chemicals, it's about humanity's journey to balance progress with responsibility. The Montreal Protocol taught us how to heal the sky. The Kigali Amendment teaches us how to protect the climate beneath it. And together, they prove one timeless truth. When science, innovation, and together, we can heal the atmosphere without heating the planet. Thank you